Welcome to Chemistry in the AM. This is post-lockdown. And away we go. We'll just do a little bit. Atoms and elements review. This is mostly grade 10, 9 stuff that we'll review. Some grade 11. So I need you guys to be aware of some things, and I think you totally are. But we're going to just get it down in writing. Particles within an atom. We've got electrons, protons, neutrons. I use, and you know this from the previous chapter, E negative for the symbol. If we need the symbol for proton, I use a P with positively charged, a letter M for neutrons, and no charge, so I can put a little zero there, okay? Now, location. Well, basically, which ones are in the nucleus of an atom? I hope you remember this. Which of these three are located in the nucleus? Protons are in the nucleus. What about neutrons? And the electrons are out of the nucleus. We're going to just say outside of the nucleus. Vaguely. We'll talk about orbitals. The relative electrical charge, -1, +1, 0, because they're neutral. And some other vocabulary to review. Atomic number is the number of protons. It's the whole number on the periodic table. So I'll just put that down first. Whole number periodic table. And it gives you the number of protons. Now, we're using the word atoms and elements, and people often use them interchangeably, and sometimes they are. Well, here's what we'll just say for an atom. It's the smallest particle of an atom. It could be. I'll only change color just so you can tell the other one's done on this one. Sorry. Yeah, I got messed up. Smallest we're not going to go into more detail, just protons, neutrons. Now, most atoms have protons in it. Hydrogen, the majority of the hydrogen atoms actually don't have. That's an exception. That's a good build. Using chemistry, you really can't rip apart an atom. That's physics. That's nuclear. So we don't get into that. What's an I in them? An atom that has gained or lost electrons to create a charge. We're E negatives for the electron. Okay. We'll talk about elements. So okay, because I said before, atoms and elements are often used interchangeably. Sometimes they're the exact same thing. An element is a pure substance not be broken down into chemical or physical reactions. Okay, I'll talk to you about this in a second. Let's jot that down. So, atoms and elements are often the same, and for a majority of the elements on the periodic table, that is the case. If I say, and you know this from reactions, I say the element iron is added to something. I'm talking about just Fe, one atom of iron. And iron is a pure substance, can't be broken down using chemical or physical reactions. You'd have to use physics, nuclear reactions. Not physical reactions, but nuclear reactions. Physical reactions are things like melting and freezing. Chemical reactions, as you know, involve basically electrons. That's chemistry. So, where an atom and an element are different is when we breathe. The element, oh, come on. What element do we breathe? Like we need oxygen. We actually breathe in nitrogen and breathe it out. So, if I say, I'm going to erase this. No. If I say oxygen, I'm talking about the element of oxygen, O2. It's not one atom of oxygen. So you see there's a distinction there. They're not the same. But there's a few others like that. And this is why I have this number 7. You're probably somewhat aware, well, oxygen has O2. These are grade 4, grade 6 students. Oxygen comes as groups of 2. I'm not saying so. What do I have 7 here? 7, 7, 7. Why? Well, because there are 7 elements that come as a group of 2. 7 is the magic number. You guys remember, the old children's story, right? 7 dwarfs. Or like the nursery rhyme you guys used to say all the time, right? 7 little chipmunks twirling on a branch. 7 little chipmunks at my uncle's ranch. 7. Like 7-minute abs. You guys have never seen something about Mary. It's too old. Don't worry. So I got the periodic table here, but here's why 7 is the thing to remember. There's 7 elements that come as a group. Now, how do you know which 7 comes as a group? Like oxygen comes as an O2. I suggest if you have a periodic table, you just say, okay, 7 of them, remember 7. You start at 7, and then you make a number 7, as you see on the page. Those are the ones. There's 7 of them. This is only 6. So N2, O2, F2, Cl2, Br2, I2, and the 7th one is hydrogen, H2. Now, I'm going to go back and we'll list this, okay? But 7 is all you need to remember there. 7 elements come as a group of 2. Start at 7, make it 7, and hydrogen's your 7. So back to the 10. 7 elements come in group of 2. This is where the element happens. We'll list them, like I said, start at 7, make it 7. Nitrogen, oxygen, fluorine, Cl2, chlorine, bromine, iodine, 7th one's hydrogen. So I think we're somewhat aware of this. I said oxygen plus hydrogen arrow produces water. You're going to put just hydrogen. It's just oxygen, not in compound. You know, on that. Okay. So if I say chlorine reacts with, I'm saying Cl2. That is only when it's by itself as an element. That's how it's found in nature. Okay. Move. Now, almost everything else comes as singles. There's two other exceptions. I won't require you to remember this. I do want you to know this. 7 elements come as phosphorus and sulfur are the other ones that come in different groups. Phosphorus is P4. If I say the element phosphorus, it comes as a P4 in nature. And sulfur is S8. Okay? Jot those down. I would remind you about those. They're not that common. For biology and stuff, I would go to open. So the acronym off-critical. If you wanted to say off-critical too. There's other ways. It's just like you want to use oil rig or Leo curve. It's just a memory, right? The 7 is exclusively mine. I think off-critical is stupid. I used to beat up teachers who are you gonna? I can't anymore. I can't anymore. Well, I'm on parole. I'm on parole. I'm not talking. I used to be. No, can't do anything. Okay. That's wacky, some teachers. Okay. So we're aware of the elements. You have your own periodic tables. But any other element that I say, so if I say helium gases, I'm just talking about one group of H2 for a balanced reaction. If I say sodium is added to, I'm just talking about Na. Not the charge thing either. I'd have to say sodium ion. I want to get it. Now, information on the periodic table. Atomic number, protons, electrons. We're not worried about neutrons. So, right away, you can find lead on the periodic table. Grab your periodic table out or look up at this. Because this one's hard to read on it. But here's PD, lead, right? Boom. Okay. 82 is the atomic number. That's directly read from the periodic. So, if the atomic number is 82, how many protons do you have? 82. This should be grade 9. Like, I think it should be. But, yeah, I was going to say, but you guys were sent home. So, half of you probably had it the semester you were sent home for. So, if I say lead and there's no charge written on it, that means you have as many positives as negatives. So there's 82 electrons. If it's a neutral atom, it's not the ion. Yes, it's neutral, no charge. We're going to assume elements, not ions. The heading there says elements. That's fine. So good question. Now, let's fill in the numbers and then we'll figure out the elements afterwards. Thank you. I'm going to just set this aside first. I don't want to misplace it. So, if I know the number of protons and the next one is 92, then I know the atomic number is 92. And I'm told that we're looking for elements, not ions, so it's going to be 92 electrons. Likewise, if we've got 30 electrons and it's a neutral element, 30 protons, the atomic number is 30. So I'm going to ask you guys to find atomic number 92 and 30. Tell me what the symbols are. Uranium and zinc. Okay. That's all good. Just review. These are things you may or may not have seen in grade 9. Board diagrams are something you may have seen in grade 10. Hopefully, you saw them, but also COVID was interrupting that year, and a lot of people were sent home for 2 weeks, whole classes were in session. Let's just do 2 or 3. Now, grade 10, you guys might have had a variety of teachers. You had Mr. Mallet. Anybody have Mr. Mallet here? Okay. You're Mr. Joe. So I think okay. If I say Lewis diagrams, do you guys know what I'm talking about? You watch karate videos?
Yeah, that was really there. And like it's possible.
Okay, we won't say this is being recorded. Okay. Extract that from the statement. Here, you know, you're one. Anyways, I'm just trying. So we'll fill in those gaps from COVID. That's what we're doing. So let's just do some examples here. Helium. So put He in the center circle. Now, here's how I suggest we do Lewis diagram, board diagram. This is going to lead to Lewis. That's what I was asking. So if I say helium, I find it on the periodic table. There it is, right? And the first ring corresponds to the first row of the periodic table. Now, I made that super large and it went off the screen. But you get the idea, right? Okay. There's only 2 spots on there. That means there's only 2 electrons. That's a memory aid to help you. The periodic table is actually lined up to help you with the number of electrons. So the first ring, the first row corresponds. So 2. And because that's a complete row, we're going to put them side by side. So 1 electron, 2 electrons. It's a complete show. You need to, and this is something the grade 9 way of doing the textbook shows how to do Lewis diagrams this way. The grade 10 textbook actually shows them in a poor fashion. Like they space them out equally. Yeah. Don't space them out.
We take it if I do space it out equally.
No, because they're a great problem. It's not that big a deal. You want pairs, and there's a rule to follow about where pairs. So I'm going to go with, say, neon. Neon is right below helium. Here's how we're going to do it. There's 8 units from them. So here's what I'm looking at. Neon has 10 electrons. 2 of them are in the first, and I just did that again. The first thing with 2. And then there is 1, 2, 3, 4, 5, 6, 7, 8 in the second. And the 8 is the max for a ring. Board diagrams are quite limited. It only works well with the first 3 rows. So neon, let's get this down. Complete first level. So 1, 2. Here's how we fill in, and the end result doesn't make a difference. But here's how we fill in the second row. 8. But think of this circle as fitting inside a 4-sided box. 1, 2, 3, 4, and then we only double up after we have 4 singles. 5, 6, 7, 8. You follow what I'm saying? This is leading into how we do the Lewis diagrams. Okay? It is 10. 8 is the second row, the outer row. First row is always 2 because it corresponds to the 2 in the first row. Always. Yeah. And I will only stick to the first 3 rings of them, or first 3 rows. So let's go to something like phosphorus. So phosphorus, P, is in the 3rd row. So here's what I'm thinking. Phosphorus has a total of 15 electrons because I'm using the atomic number. But I don't think of it as 15 electrons. All I think is 2 in the first row, 8 from the second row, so 8 in the second ring. Then we'll fill in the last ring. So, 2, 1, 2 pairs. 8, and I know already that it's going to completely fill up, so I'm going to just put them as pairs right off the bat. And then I've got to count all the rest of the phosphorus. There's 5, and I'm going to just show that on the screen. 1, 2, 3, 4, 5 in the third ring. 5 on the outer ring. 1, 2, 3, 4. I've got 4 singles, and now I double it up. 5. This is important to think this way because it leads to our understanding of how to do Lewis diagrams. Essentially, Lewis diagrams are just the outer ring without a ring. The outer electrons from a Bohr diagram. But you've got to pair them up in this fashion. We just simplify it by not showing the inner ones and show which ones are paired. Okay. So that's a review for today. You guys have done them. Like I said, the only difference is that I'm going to ask you guys to pair up